right, chapter 10, section 4, we're covering inscribed angles and polygons. Inscribed angles and intercepted arcs. Inscribed angle is where the vertex is on a circle and whose sides contain chords of the circle. So one of the lessons we covered central angle. Keep in mind central angle was the same measure as the arc. This is a little different. So my inscribed angle goes all the way across on my circle. Okay, it doesn't stop at the center, it goes straight across. So when you're looking at it, please understand that it goes all the way across. And then this is my intercepted arc, the arc that lies between the two lines, rays, or segments. So yes, this is a ray. It has an endpoint and it continues. You could have a segment or you could have two lines. So the arc is what's in between those two. Okay. Something that, again, I'm going to write on here just so we know. We had central angle. And that's when the vertex was at the center. Okay, so keep that in mind. Central angle is different than inscribed angle. All right, looking at this one, the measure of an inscribed angle theorem. So you have to know how to find an inscribed angle or an intercepted arc. So that's what we're going to learn. It's either you're multiplying by 2 or you're dividing by 2, and I'm going to draw the difference. So the measure of an inscribed angle, that's the angle, not the arc. So the angle is 1/2 the measure of the intercepted arc. So I'm going to draw this for you so you get a good understanding of what they are and how to find them. Here's my circle. Let's say that this is my inscribed angle. If they're giving me the measure of my arc, let's say the measure of my arc right here was 100 degrees. Okay, I'm just going to keep it in black. Let's say this was 100 degrees. How would I find this angle? How would I find the angle? Think about it. Am I multiplying by 2? Would I be dividing by 2? Good. So for this one, in order for me to find this angle using my intercepted arc, I'm going to go ahead and I'm going to solve it by dividing. 100 divided by 2, it's going to give me 50. So this angle right here is 50 degrees. Okay, that's given the arc. Given the arc, I have to find my angle. So that one is this right here. So I'm dividing by 2. Drawing another one, giving you another example. Okay, so here is my inscribed angle. Let's say they're giving me my angle, and my angle is 35. How would I find my arc? Good, I'm going to do 35 times 2. What's 35 times 2? 70, and that's how I'm finding my arc. So understand the difference. Either you're multiplying by 2 or you're dividing by 2. And then I'm just going to give you an example of central angle just so we remember. Here's my circle. My central angle is in the middle. So let's say this right here was 95 degrees. What's the measure of the arc? What will the measure of the arc be if they're giving me my central angle? Good, okay. So central angle and the arc are both the same measure. So you have to remember that. When it's giving you the center point, it's the same. But inscribed angles are different. Okay, do we have any questions on this? The measure of an inscribed angle theorem. Okay. Inscribed angles of a circle theorem, it says, if two inscribed angles of a circle intercept the same arc. Okay, if they intercept this same arc, I'm going to highlight the same arc so we know where it is. Okay, I'm going to highlight it in green. It says then the angles are congruent. So looking at it, where are my two inscribed angles? My two inscribed angles, I have one here and one here. The same arc is in green. This is my same arc. Okay, so if they're intercepting the same arc, then the two angles are congruent. So that means angle 1 and angle 2 are the same measure. So if you think about it, let's just give it a measurement as an example. If this arc, let's say, was 50. Now look at my inscribed angles. I have one here and I have one here. How would I find the angle given the inscribed arc? What would I have to do to find my angle? Yeah. Divide by 2. So all I have to do is take 50, divided by 2. What is that going to give me? I'm going to get 25 here. And because this has the same arc, what is this angle as well? 25. Okay, so please understand, if they're sharing the same arc, the angles are going to be congruent. So you have to be able to identify the angles with the arc. So I understand it could be hard and difficult for some students, but please practice it. All right, inscribed polygon and circumscribed circles. Inscribed polygon, just so you know, the word inscribed, some of you are probably wondering, what does that word mean? It just means inside. Okay, so that means I have a polygon inside my circle. Okay, a polygon with all of its vertices in a circle. So if you're looking at these diagrams, notice that all the vertices of my polygon is inside my circle or on my circle. Okay, but it's inside the circle. Then I have circumscribed circle. That's the circle that contains the vertices. Okay, that's the circle that contains the polygons. So just vocabulary here. Inscribed right triangles theorem. Okay, pay attention to what it says. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Okay, super important that you're able to identify that. If they're giving you a right triangle inside a circle, inscribed in your circle, then your hypotenuse is your diameter. It's going to go through the center of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite to the diameter is the right angle. Okay, so when you're looking at this diagram here, a couple things that we should know. If we're looking at it, it goes straight through. This is considered my diameter because it goes straight through the circle. So I'm just going to go ahead and write on here that this is my diameter. And if it's my diameter, it's also my hypotenuse of my triangle. So keep in mind, it says opposite the diameter is your right angle. This right here is my right angle for this right triangle. So please be able to identify right triangles within your circle. Inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. What does that mean? What does supplementary mean? Does anybody remember? Good. Okay, if and only if the opposite angles equal 180. So if I'm looking at this diagram, This is a quadrilateral if and only if my opposite angles equal 180. So that's angle 2 and angle 4. Okay, keep in mind it's the measure of those angles. And then I also have 1 and 3 are opposite angles. Okay. All right, useful fact. An angle inscribed in a semicircle is a right angle. So that's the same thing that we kind of went over. If you have a right triangle, yes, this is a semicircle because this is my, again, diameter. Then the angle inside my semicircle is a right angle. So angle 1 is a right angle. All right, solving. Solving for these examples, it says find the values of x and y in circle O. Please pay attention and please be able to identify these. I'm going to go as slowly as possible. So looking at it first, I can see that they're giving me this arc measure, which is 110. And I know that I have an inscribed angle according to my intercepted arc. So if I'm going from one end of my arc to the other end of my arc, I'm able to find this angle. How would I find that angle in blue? What am I dividing by 2? I'm taking that 110, dividing it by 2. If I divide it correctly, what would I get? 55 degrees. So I'm going to go ahead and label that there. All right, other pieces of information I know. This angle right here is 20. Okay, this is my angle. That means this is my arc right here. So what would x equal? 40, I'm multiplying it by 2. So 20 times 2, just writing it. Is there another angle that shares this arc? Look at it carefully. Is there another angle that shares this arc? Yes, there is. It's this angle right here. Okay, here's that angle. It shares that same arc. So if they have the same arc, the angles are congruent. This is also going to be 20. And then they're asking for me to solve for y. So solving for y is this angle right here in green. It's the entire thing. How would I find y? How would I find y? Add 55 and 20. So 55 plus 20, what would I get for y? Good, 75 degrees for y. Okay, you could also look at it if you want. You have the entire arc here. Okay, this entire arc. You could then divide it by 2 to find your angle. There's quite a few ways to find information on here. Okay, looking at B. Looking at what they're giving me. The first thing I'm able to identify is that they're giving me this angle measure right here, which is 20. So drawing that angle, identifying my intercepted arc right here. What's the measure of this arc? 40, good, 20 times 2. Is there another angle that also equals 20? Is there another angle that shares that same arc? Yes or no? Huh? X, good. So drawing that angle right here, just so you're able to identify it. Yes, this is X, which is also 20 degrees. Now I have to find Y. Looking at Y, this is angle Y. I'm going to go ahead and trace that angle. Here is Y. So that means I'm looking at this entire arc right here. Who could tell me, what does that entire arc equal? Good, 180, that's my semicircle. It's the measure of a semicircle. So if this entire arc is 180, how would I find the measure of angle Y? 90, so I have to what? Good. 180 divided by 2 would be 90. Say it one more time. Yes. Yeah, you could also look at it and say, okay, I have a right triangle right here, if you were able to identify it. Yep, this is then 90 degrees. Yes, that's another way you can identify this, because my hypotenuse is my diameter. Yes, you can use the theorem, the inscribed right triangles theorem. Okay. All right, solving for these examples, again, we're looking for x and y, looking at this one here, finding out what they're giving us. So looking at it, this arc is 140 degrees. So I'm able to find this angle. What's the measure of this angle right here? 70. I'm going to take that 140, divide it by 2. I'm going to get 70 degrees. All right, finding x. This right here is 60 degrees. That's what they gave me. So if this is 60 degrees, how would I find x? How would I find the measure of x? No, because they're giving me my angle. Again, this is my inscribed right here. So that means this is my intercepted arc. So all I have to do is 60 times 2. That's going to give me 120 for x. And then finding y, how would I find y? Trying to solve for y right here. How would I find y? Subtract what? Good, so I'm going to go ahead and add 140, 120. I'm going to get 260, and then 360 minus 260. Y is going to be 100 degrees. One more thing, how would I find the measure of this angle? What is it? Divided by 2, what would that be? 50 degrees. Going to the next example, the last one. What do I have here? I know this is a little not drawn straight, but this is my diameter. Okay, if it was drawn straight, this should be your diameter. If that's my diameter, what do I know about these two shapes? Yeah. They're both right triangles. So remember, your right angle is opposite your hypotenuse or your diameter. So it's right there. So information that we do know, one is that this arc right here is 80. And if I'm trying to look for that inscribed angle, that would give me my x. What's the measure of x here? How would I find that measure of x? Sorry? You divide by 2, so 80 divided by 2 would be 40. Good, 80 divided by 2 would be 40 degrees. What would the measure of this angle right here be? Which one? The blue one. 50. All right, a couple other pieces of information that we're able to find. What would this arc be? 100 degrees. Those two segments are congruent, so what would y equal? 50 as well. All right, questions, comments, concerns on this? Keep in mind, if these two are congruent, that means my arc is also congruent. So just so you know how we got that 50, that means this is also going to be 100 degrees. And then it's the measure of this angle. Questions, comments, concerns on these? Okay.